Hello guys, my name is Hindu Mukhopadhyay. Today I will be discussing our strategy design pattern. So in strategy design pattern, there's going to be a client who is going to be using some choices to go to the airport. Now, the client will be choosing the choices depending on the situation. Let's say the weather in here is going to be the situation. So let's say that it's sunny. So he is going to be using the bus. So like that, the client will be choosing which choice he will be using to go to the airport. Now there's something called the runtime polymorphism in here. So in this project, or in strategy design pattern, there's something called the runtime polymorphism which is being used. So in the runtime polymorphism, the client will be choosing the choice that he's going to be using to go to the airport when the program is getting executed. So now let me give you an example. Now there has been me and my dad have found out the missiles algorithms. One is the Runge-Kutta and another is the trapezoidal rule. So both of the the missile will be using the choices depending on the situation. So let's say that strategy pattern is getting used there. So since whenever it needs it will have to choose this or that. So it's technically strategy design pattern. So now I'll be sharing my screen. Bye.
This is me, Som, and my son Ridit, 11 years old boy from Bharat. Yes, currently Ridit is being homeschooled. I mean, not homeschooled, he is being part of no schooling. And Ridit is actually in class 6, but Ridit is kind of already an accomplished computer science engineer.
Yes.
Right, beta? Yeah. Ridit is already an accomplished computer science engineer, and because Ridit has been learning computer science since pretty early, since when he was 6 years old. Yes, is it?
Yes.
He started with Scratch, and then what is that called? Java, and then he picked up the first language, high-end computer language Ridit learned was Java. Then Ridit went into picking up Python. Then Ridit learned C++. Now Ridit's C++ journey has a special purpose because Ridit is going to delve into the natural process simulation for his research area. Okay, we have chosen natural process simulation for Ridit's research area, and to start with natural process simulation, we have started with fluid simulation. Right, beta? We have started with fluid simulation. So to start with fluid simulation, we have chosen the MantaFlow of Blender. Now the most of the code, 70 to 80% code of the MantaFlow is written in C++, and therefore Ridit has to become an expert in C++, and that's why Ridit started his C++ journey almost 1 year back, beta?
Yes.
Almost at least 7-8 months back, and Ridit has already become pretty comfortable in a lot of C++, including the new memory management that has been done by the boost point, right, beta?
Yes.
That boost point, right? So Ridit is kind of very conversant on weak pointer, shared pointer, unique pointer, right, beta?
Yes.
Ridit mostly uses all sorts of what is that called? Bush pointer.
Yes.
For all his work
Unique
at this
pointer.
moment. So unique pointer, bush pointer and shared pointer, everything Ridit is very comfortable with all these things. Ridit also has a blog, technical blog, in which he has discussed many aspects of when his experience of going to the GCC libraries, boost pointer, right, beta?
Yes.
He did also research, and so Ridit, we are kind of making Ridit a formidable intellectual kshatriya to work for Bharat, and so I hope one day Ridit will be able to play a big role in the technical domain, not only in the technical domain, as a visionary technical leader of Bharat. Jai Hind. So Ridit, today, because as we have already discussed, Ridit, our goal, my goal as a computer science guru of Ridit was to make Ridit get the big picture first. So that's why Ridit learned design pattern and UML before learning data structure. And mostly, so Ridit, because Ridit is almost, the MantaFlow development environment is ready in both my machine as well as Ridit's machine. But as I'm getting a little bit of kind of, lot of things and held up with lot of things, so the research is yet to start. But yeah, we have started the source code, we have started many parts of the natural process, fluid simulation of MantaFlow. We have run the development environment of MantaFlow in Ridit's machine as well as my machine. But the real source code study or the in-depth analysis of fluid simulation is yet to start. But very soon probably it will be on. In the meantime, Ridit is spending time making his skill powerful in C++ and many things. Of course, Python is also there, but mainly Ridit is now concentrating on C++ and the uses of MantaFlow in Blender, right? So Ridit, just few days back, Ridit was developing very nice fluid simulation using MantaFlow, but now again he has come back to the software part, because anyway ultimately he will have to get the do the research of MantaFlow source code using the C++ source code, right, madam?
Yes.
So Ridit can show you the, or maybe we have already shown you the how the development environment is being ready for the MantaFlow on Ridit's machine as well. So Ridit today, because for the last 2-3 days, Ridit is been practicing design patterns, various gang of design patterns from using C++. So today Ridit has done in the morning that the strategy pattern, right? So that's what Ridit will tell you now. See, this is the strategy pattern. See, the screen recording is strategy pattern. Ridit, you can whatever you wish to say. Go ahead.
So in strategy pattern, usually there is a client which is going to be choosing which choice that he is going to be executing at the runtime. Yes. So let me give you an example. Suppose the client has to go to the airport and it is raining. So the client will be choosing which vehicle to use while it is raining. And he will see that when he is outside, not when he is inside the home, or more likely to say when it is running, when the application is running.
That means runtime. So it will be statically. So that means he will always choose bus or Rapido or Ola. No, but depending upon the situation, you will get the sense of the environment. Okay, this is now raining, so I will choose this. Yes.
And this is called runtime polymorphism.
Runtime polymorphism that is being used as a strategy. So there will be same strategy. So for airports, there may be 3-4 methods. Like go ahead, better. Like by bus, by Ola.
By bus and by Ola, by Rapido. So as you can see, there is an interface here, which is the journey to the airport. So in the interface, we have made a method which is called go to the airport, which is a pure virtual function.
Pure virtual function. That means that this interface this has become an interface, because the moment a class C++ normal class is a pure virtual function, it will become an interface. Yes. Java
so
interface.
That means that it has to
implement whoever class is implementing it has to implement this method, override this method. Yes. Go ahead, Vita.
So there are these side classes or the concrete classes. Like the by bus, by Ola, and by Rapido. These are all the choices.
Open one bit of one by Ola or by Rapido. Okay.
So this is including the journey into the method.
Because that's okay. Yeah, that's okay. Yes. And then go to the CPU file, beta. CPU file.
Okay.
So CPU file this is simply doing.
He is showing a message whenever you are going to be choosing the choice. It is going to be showing the message
that this Ola has been chosen, but whatever. I mean, so this is the simplistic form, but actually in actual code there will be a lot of algorithm, a lot of things after choosing the yes.
So in a missile, there's in the structure of a missile, my dad and I once saw that there were 2 algorithms. One the Runge-Kutta and another was the trapezoidal rule.
So actually what Ridit is saying is we started one missile simulation. Started in that sense, we took the PDF, downloaded the PDF from internet, and the missile simulation, right? Beta missile,
Yes.
missile simulation, missile launching simulation. Where yes, go ahead, beta. Two
So,
algorithms
two
were there.
algorithms were there.
One was
One was the Rangekutta and another was the trapezoidal rule. So that will be chosen when it is needed.
So again, that was a part of strategy pattern. So
Yes.
they have used strategy pattern to pick up the right algorithm, right, beta?
Yes.
Yes. Go ahead. So this is the same strategy pattern. So see, the basic idea is that the same strategy pattern can be used in missile simulation. Same strategy pattern can be used in this much simple application, but the strategy pattern is same. So that's why I always say getting the bigger picture is more important. So once you understand the strategy pattern, that missile simulation software where this any one of the algorithm, either Rangekutta or the trapezoidal rule are being picked up using strategy pattern, will be very easy for Ridit to understand, right?
Yes, yes.
That's why I always advise to get the bigger picture. Go ahead, better. Go ahead.
And so I'm going to be showing the main right now.
Yes.
So in the main, we are using the unique pointer as my dad said. I use boost pointer mainly.
Yes. Ridit mostly uses all the boost pointers. So first it is initializing into the null pointer,
Yes.
and then
we are going to be asking the client
yes.
to choose which vehicle is he going to be using.
Yes.
So then we are making the string choice, which is the choice, and then there is scene, which is the input. Like
Input, yes. Input
yes,
from console.
scene, yes.
Input console input, right?
Yes,
Console
yes.
input. Yes. So
Like in Java, we used to use
what is that called? System router, println, and all these things.
yes,
Right? Yeah.
inline and all that.
Yeah. I have forgotten. Yeah.
Yeah, I
No
know.
worry.
So we have also made this. If choice is equal to Ola, we are going to be making a new by Ola class or an object
Right.
actually. So we are going to be using the move method obviously. Since we are going to be moving all
Unique
this.
pointer. So because you cannot
So-
copy
yes.
we cannot copy a unique pointer, right? So naturally,
it's all
when this
unique.
make unique, you have to move the pointer to this.
the
So
journey
this
to the
pointer
airport.
make unique will create a unique pointer.
Yes.
Then we'll have to release the ownership
Yes.
so that it goes to the journey to the airport, right?
Yes.
That's what. Yeah.
And we have done the same to the rest of them, as you can see.
Option and then.
And then we have finally called in the method go to the airport.
Yeah. So see, because this journey to the airport is a unique pointer, right? So now as the name says a unique pointer, it cannot be copied.
Yes.
Naturally, so when you are doing here this one move, that means you are basically creating a pointer, but then you are transferring the ownership to the left side, that is the journey to the airport, because this is also a unique pointer. Once this line is executed, then that means the journey to the airport will have a unique pointer having the Ola type, right, brother?
Yes.
So then naturally it will be called, right? Go to the airport. For Ola it will be called runtime polymorphism.
Yes.
That's what it will be. Because the type is Ola, so naturally it will be called, right? It's a runtime.
Yes.
The type is you journey to the airport, but the actual object is Ola, so runtime polymorphism. That's what, right, brother?
Yes.
So this is why don't you run it?
Yes.
So
Let's
let us run. So this is this is the basic idea of strategy pattern. We will pick up a choice in the runtime. Go
So
ahead.
let's choose bus.
Yes, bus. So see, the bus is going to the here.
Yes.
This is what the main idea of the strategy pattern. Jai Hind everybody. Congratulations, Nidit.
Now let's use Ola.
Oh, okay. What is Ola, and that's the Ola is going to the airport. This is how the strategy pattern is being implemented. Console. So yeah, go ahead. Rapido and Rapido. Very good. Get Nidit. Get. Jai Hind. Jai Hind, everybody.